Assalamu alaikum. I hope you all are fine. Today we are going to start the last exercise of third chapter 3.4. The important questions according to board and that are in past papers are question number 5, 6, 7. So we are going to do that questions in today's video. First important question of exercise 3.4 is question number 5, that is, let a set C contain 2, 4, 6 element, D contain 2, 4, 6, 8, 9, 12, and relation between them in set builder form is that xy such that x belongs to C and y belongs to D and x is a factor of y. Write R in tabular form. So first we have to write the R in tabular form, that is the order pair form. For this, first we have to find the cross product of C and D. Here x is a factor of y means that both x and y elements are completely divided to each other with zero remainder. So first we find the cross product of C and D. Here we write the cross product of C and D. Since the element of C contain 3 and there are 5 elements of D set, we multiply 5 with 3. So the resultant order pair are 15. There are 15 order pair in C cross D. We have to select the order pair which fulfill the condition of R set builder form, that is x is a factor of y. So in tabular form we only write those order pair which fulfill the condition that the y element is completely divisible by x element. So we write R in tabular form as the first order pair in which y is completely divisible by first element is 2, 4. Here 4 is completely divisible by 2. Then we write the second order pair which fulfill the condition is 2, 6. Third one is 2, 8. Then 2, 12. 4, 4. 4, 8. 4, 12. 6, 6. And 6, 12. So this is the tabular representation of R in which we write the order pair which fulfill the condition. Here R in tabular form is this. So we have to find the domain of R. Domains means the first element of each order pair, like 2, 4 and 6 is the domain. So we write it as domain 2, 4, 6. Range of R equals to the second element of the order pair, like 4, 6, 8, 12, and then they are repeated to each other. So the range of set R equals to 4, 6, 8, 12. 4, 6, 8, 12. Find R inverse. Since R in tabular form is these 9 order pairs, so for R inverse we have to change the domain and range of each order pair. Here range become domain and domain become range of each order pair, which is the R inverse. So R inverse is equals to, just change the order of each order pair, that is 4 to 6 to 8 to 12 to 4, 4, 8, 4, 12, 4, 6, 6 and 12, 6. So here we have to represent our relation by arrow diagram. So first we write the element in first set. We call it first set A and it B. So we write the all element of domain in set A. So domain equals to 2, 4, 6, and all element in B set are range elements, that equals to 2, 6, 8, 12. Now we have to represent it by arrow diagram. By arrow diagram we can show the arrow like this. 2 is the factor of 4, 2 is the factor of 6, 2 is the factor of 8, 2 is the factor of 12. Now with different color we write the we denoted the factors of 4. 4 is a factor of 4, 4 is a factor of 8, and 4 is a factor of 12. Now 6 is a factor of 6, and 6 is a factor of 12. So this is the arrow representation of set R. Question number 6 is, let R set in tabular form contain the order pair 2 0 4 2 6 4 8 6 and 10 8. So we have to write this R in set builder form. For set builder form we have to build a relation between x and y order pair. Here you can see in rough work that first order pair 2 comma 0, it means if we subtract 0 from 2 we get the answer 2. Second order pair 4 comma 2 equals to 4 minus 2 equal to 2. Third is 6 4, 6 minus 2 equals 6 minus 4 equals to 2. Then 8 6, 8 minus 6 equal to 2, and then 10 8 comma 8 equals to 10 minus 8 equals to 2. So from each order pair you can see if we subtract second element from first we get the answer 2. So we write it in general form at, so this implies that x minus y equals to 2. So we write it in set builder form and write it as R such that comma x comma y, x minus y equals to 2. This is the set builder form of R. In second part we have to find the domain and range of R. So in set builder form you can see that R order pair are written as 2 0 4 2 6 4 8 6 and 10 8. So domain is the first element of each order pair. Here the elements of domain are 2 4 6 8 10. So we write domain as 2 comma 4 comma 6 comma 8 comma 10, and range are the second element of each order pair, which are 0 2 4 6 8. We write it as 0 2 4 6 8. In second part we have to write R inverse in tabular and set builder form. So in tabular form, as in question, R is written in tabular form. So to find the R inverse we have to interchange the position of elements, like we have to interchange domain and range of each order pair. So we write R inverse in tabular form as 0 2 2 4 4 6 8 6 and 8 10. And in set builder form, how we write R inverse? Here the set builder form of R is given. So in R inverse form we have to interchange the variable x and y. So we write it in set builder form R inverse as y comma x such that y minus x equals to 2. So this is the representation of R inverse in tabular and set builder form. Last part is represent R and R inverse by arrow diagram. So first we find the arrow diagram of R between set A and B. In set A we write the all domain elements of R. So the domain element of set R are 2 4 6 8 10, 2 4 6 8 10, and in B set are the range elements that are 0 2 4 6 8. So in arrow diagram, 2 is the 2 is related to 0, 4, 6, 6 is related to this, 8, and then 10 is related to y. And in R inverse we have to write the elements of A, domain elements of R inverse. Domain elements of R inverse are 0, 2, 4, 6, 8. 0, 2, 4, 0, 2, 4, 8. मैं क्या कर रही हूँ? Question number 7 is let A set contain 0, 1, 3 and B contain 1, 2, 3, 5, 7. Then there is R set which write in set builder form that x, y, x belongs to A, y belongs to B and y equals to 2x plus 1. So write R in tabular form and also find R inverse. So first we find the cross product of A and B, that equals to, we pair 0 with all element of B first, 0, 1, 0, 2, 0, 3, 0, 5, 0, 7. Now we pair 1 with all element of B set, that is 1, 1, 1, 2, 1, 3, 1, 5 and 1, 7. Now pair 3 with all element of B, 3, 1, 3, 2, 3, 3, 3, 5 and 3, 7. This is the cross product of A and B. Now we have to select those order pair which fulfill the condition of set builder notation that y equals to 2x plus 1. If we select any order, like if I select the first order pair, that is 0, 1, so here 0 is x and y is 1. So put these variable value in the equation y equal to 2x plus 1. If it satisfies the equation, then we write this in tabular form of R. Here I put x equal to 0 and y equals to 1 in the equation. It becomes 1. It become 1 equals to 2 multiplied by 0 plus 1, as 2 into 0 equals to 0. So 0 plus 1 equals to 1 and 1 equals to 1. It means that the order pair satisfies the equation. So in tabular form we write R equals to 0, 1. Similarly, we check each order pair. Like if I check the second order pair, that is 0, 2. If I check it and I put x equal to 0 in it and y equals to 2, then it does not satisfy the equation. So the only order pair that satisfy the equations are 0, 1, 1, 3 and 3, 7. As you can check on 0, 2 that it does not satisfy the condition. X, y equals to 2 and x equals to 0. As 2 is not equals to 1, so we does not include it in tabular form of R. So the only 3 order pair that fulfill the condition y equals to 2x plus 1 are 0, 1, 1, 3 and 3, 7. This is the tabular form of R. Now we have to find the R inverse. R inverse mean that you have to interchange the position of element of each order pair. Like you have to change domain and range position. So first order pair become 1, 0, second is 3, 1 and the last is 7, 3, which is the required R inverse representation in tabular form. So here we have completed question number 7.